All right, and I believe next we are going to listen to our friend Mr. Timur Pulathaneli once again. Yep, you're all set, sir. Now he needs to get a microphone first. Do you want a handheld?
Sorry. Just had to check. 1, 2. Yep. Okay, I just had to see which microphone I'm using. Okay, perfect. That's much better. So, welcome back, everybody. So that was the fun part. That was
no
looking at our hackathon winners.
Congrats, man. Thanks.
Scott still there?
I'm still hot.
You can talk still if you want.
Okay. There.
Switch it off. All right, so that was the fun part, saying hi to our hackathon winners and looking at all the cool apps they created. So what we're going to do now is we're going to go and have a look at all the tools that we have available in the SDL ecosystem. So it's going to be like 45 minutes of actually more like working level tool chain that we have and what we're doing to actually advance SDL and improve SDL. So let's get started with a little overview. So we're going to go through what we have for iOS and Android and also for our core system and what kind of tools we have available for development and what kind of tools we have available for the OEMs to develop. We're going to go through documentation, see how we do documentation for the SDLC, how documentation is managed and the process of how documentation is changed and then shown to developers. A little bit on smartdevicelink.com, on app IDs, how is SDL developed, how do we decide on new features, and then how you guys can contribute and how people contribute in general to the SDL ecosystem. So first of all, quick introduction on what we use to host our source code. So generally, we work with Git for version control, and we host that on GitHub. So as I said before, on github.com/smartdevicelink, we have a couple of repositories, 35 at the moment, where we host all our various projects. And for the development part of this, we actually work with what is called Gitflow. And I'm not sure if you ever work with Gitflow, but it's a methodology to branch out and merge your project so that you have a very defined set of branches online, and you can always know what branch is merged into what branch at what stage in the process. This is just important for people that actually want to contribute. If you want to go in and create a hotfix for a project, it is important to us that you follow the Git flow process and create branches and with the right hotfixes and stuff like that so that we can easily merge them back together. The other thing we do use is what is called semantic versioning. So I know this is something that people don't often think about, but when you see a version number of a project, these 3 numbers that you usually see actually mean something. So for our project, we follow the semantic versioning scheme, which means something like XYZ. So for example, the Android library currently has version 4.4.0. So if we now bring out a version 5.0.0, that means we change the X, which goes into changing getting out a new major version. This means we can have some incompatibilities to an earlier version. So when we move from 4 to 5, it could be that you have to change your app. So when you think about library versions, when we switch from a library version 4.00 to 5.00, this means something in the app could be changed or could have to be changed to actually be still compatible. This is true for all the major version changes. So when we go to the Y in the scheme, so moving, for example, from 4.3 to 4.4, and we change the minor version number, that means something has been added. There's a new feature, there's something new in the code that you can use, but it's not incompatible to the early version. So you always be able to drop in a 4.4 replacement into your app that currently uses 4.3, and you're gonna be fine. And the same is actually also true for core. So if you're an OEM and you get an update to SDL Core 4.5, you can put that into the next version of your infotainment head unit and just use it without changes. These version numbers, these version upgrades are backwards compatible. When you go and when we update the Z in the scheme, so we go from 4.4 4.40 to 4.41. This is actually what's called a patch version. So we upgrade the system to a higher level, but it's really just a bug fix. So there's no additional features. There's nothing that is newly added to the system, but it's usually some kind of hot fix and some kind of fix that we had to make to the system and release to our users. So hopefully you won't see these kind of versions too often, but usually we're going to move from like 4.4 to 4.5 to add new features. And then every once in a while, you just have to break functionality to keep improving your system. So every once in a while, you're going to see upgrades of the major version, as we're going to have, for example, later this year with our iOS library. I'm going to talk about this in a second, where we're going to make incompatible changes and you won't be able to convert your current app without upgrades to the app. So developer tools, we're starting with iOS, and our iOS library current is the version 4.7.0, and 4.7.0 was released a couple of weeks ago with a lot of good changes that we made in the last couple of weeks. You see, we already are in minor version 7, so we did do a lot of good improvements to the version 4 of the library. The next planned release will be 5.0.0, which means, as you can see, this is a major change. So this will be an incompatible change to the current version of 4.7.0 if you use an old way to manage SDL. So the highlight of this change will be that we actually changed the way you access the main object that sends out RPCs to the head unit. So if you imagine you're an iOS developer and you used to access or create a specific object that managed the connection to the head unit, that was a very low-level object that was used. And for us, in our versioning scheme, it is very hard. If we give the developer access to this low level, it is for us very hard to change anything without breaking code for the developer. So what we're going to do in version 5.0.0, we're going to introduce what we call the SDL manager for iOS. So the SDL manager actually abstracts the control out one level, so the developer will handle and will communicate with the SDL manager, which in turn internally will communicate with like the lower level functionality. But this will allow us to put all the low-level functionality into private functions, meaning we can change them without actually affecting any customer and any developer functionality. So version 5.0 will allow us, with the abstraction layer, to be able to improve the plumbing of the system really a lot, the plumbing of the iOS library, and improve the functionality that is inside without actually having to do major versions all the time and even without doing a lot of minor version changes. The downside of something like this is whenever you make APIs private, all of a sudden developers cannot access them anymore. So now it's a major change because it will break some implementations. If you just drop in, let's say you're a long-time SDL supporter and you created your app 2 years ago and you used to access the SDL proxy object all the time. If we make that private now, you will not be able to access that anymore. So that means this version upgrade from 4.7 to 5.0 will break your implementation, and you have to go in and use the upgrade guide we have to now use the SDL manager object instead of the SDL proxy. It is worth it. It makes sense to update. It is not very hard. We do have a guide, and we're going to have, as soon as 5.0 is out, there will be documentation going with it telling you how to upgrade. Also, because we planned this early on, since version 4.3.0, the SDL manager object is actually already there. So if you had an integration that you did after 4.3.0 and use the guides that we have online right now, this will actually be not a big deal for you. But for a lot of our very old partners, they're going to have to do some changes to their application. And this is why we upgraded this to 5.0, so we show that this is a breaking change that you cannot not necessarily just drop into your application. So just that you know how you can get that library, CocoaPods for iOS, cartridge, and just you can download the source code really and compile it into your project if you're interested. And this only means things to iOS developers, so if you don't know what it is, no harm. Unless you want to develop for iOS, then you should really know what this is. But you can get your applications, you can get your stuff from there, not a big deal. And then we have one other thing. I just want to make you kind of aware of these work streams we have and kind of the things we think about when we create a library. So for us, it's always important is what is the minimum version that our library should support. Because if our library, let's say our library only supports minimum version iOS 7.0, then any app that integrates our library cannot target a lower version. It has to be the same as our library. So this means if we upgrade our library to a newer version as a minimum version number, we cut out all app developers that want to support lower versions of iOS. So now with the current library, we support 7.0 as like a minimum version. Now we're going to upgrade with 5.0. Another breaking change is we're going to upgrade the minimum version to iOS 8.0. So for iOS, to be honest, it's not that big of a deal compared to Android necessarily, because iOS has a very fast adapter rate. So if you look at this chart, and I pulled this a couple of days ago, and you can see that iOS 7 has like 89%, iOS 9, 9%, and then everything earlier is just 2% of the market. So for us, we look at these kind of data to make these decisions if we want to upgrade or not. And what I kind of want to show you here is that when you develop a tool, when you're part of the SDL consortium and try to develop a library for a lot of app developers, there are a lot of challenges that you face and kind of like a lot of things that you have to look at before you can actually go and just release something or go through something. And it kind of gives you a perspective why we have an evolution process, why we have weekly meetings where we discuss stuff like this. It is because we need a lot of input and a lot of information to make the decisions like that. So we also have a Hello World application. Like everybody, you should have a Hello World application. And this is more an FYI slide. You can go to GitHub and you can look at our Hello World application, which is updated for every release we have. It's also available for Swift and Objective-C. And so you can have a look at the source code for Swift and Objective-C to see how a very basic app link or smart device link application looks like. And then we have what we call the RPC Builder app, which is a little bit more interesting also to the OEMs in the room. So the RPC Builder app allows you to basically send any RPC you want. So it's a free tool as well. It is up on our GitHub page, and you can download it and compile it on your Xcode. You give it what we call a mobile API XML. You can find that one on GitHub as well. And it will automatically, from that interface definition, it will automatically create all the screens in its application and will allow you to send any RPC. So when you look at the interface here, basically it will give you all the options to set up your app. You give it an app name, and everybody who was participating in the hackathon yesterday will be familiar with all these options. It's basically like your app name, your VR synonyms, your TTS name, and stuff like that. And then in the second step, after you connect it, you can see here, it will just allow you to send anything really that you want to send. So you want to try out your OEM implementation on your head unit, you can use this application to send any RPC, and you can see how your system reacts. And additionally to that, there's also a module functionality. So you can build new plugins for it. So the current version that's online has two plugins. One is for video streaming if you're a navigation app, and if you want to test the head unit, you can use this to test a video stream of the camera. And the other one is audio capture. So that's basically uses audio pass-through to capture data from the head unit. So this is our open source testing app for the head unit, and you can look at the source code. It's actually quite intelligent and neatly done, so it's a very, very good app to kind of test SDL, play around with it, and try to understand how it works. Then we have a Relay app. So the Relay app is a very useful tool for iOS developers specifically. So the big problem when you're an iOS developer and you want to develop an app link application against real hardware is that iOS currently on Ford vehicles requires a USB connection, so you have to plug in your phone to connect the app link application or the smart device link application. But iOS also requires a USB connection to your computer to do live logging and to do breakpoints and to do debugging. Now, tough choice, you got to connect to one thing. So it was really hard to debug your iOS application because you had to plug it into your TDK, you would then run it, and something would go wrong, you plug it back into your computer, and you would go back and forth. Now the Relay app is a pretty nifty application that allows you to basically use something to go in between this connection. So this is how it would look like for your normal connection. So your app would connect directly to USB. Now, for the Relay app, what you do is you have the Relay app and it opens a TCP/IP server. So it's basically just connected through Wi-Fi or something like that. And the Relay app is plugged in to your TDK. So the Relay app runs on its own iOS phone that's plugged into the head unit via USB. Your application runs in a simulator on your computer and connects to this Relay app via Wi-Fi. So that means you can do live logging, you can do breakpoints, you can do all the fun stuff in iOS at the same time as you're testing against real hardware. So this was really good. It was really appreciated by our iOS developers. But unfortunately not, but iOS 11 will actually bring out a new feature, which is wireless debugging, where you don't have to plug your phone in to connect it to Xcode and to live debugging. So now with iOS 11, this tool will be a little bit obsolete, but we're going to keep it around in our open source GitHub in case anybody wants to use that. So you can also go to that URL and just download the app and compile it and use it for your development. Couple of screens here, you see like the TCP/IP server and you see the disconnect connect status messages. So it's a very basic functionality, but it just basically helps you to connect. For Android, we're currently at 4.3.1. So the next planned release is 4.4.0. So we're going to work on that, and we have a couple of things we're going to change there. One of the bigger ones is that we're actually going to put smart devices on bin tray, and I'm not sure how many Android developers we have around here, but the way you get your libraries from CocoaPods or Cartridge on iOS, you can get them through Gradle, through bin tray on Android. And with Android, with our library 4.40, we're going to join that so that you can easily include it into your project. Additionally, we did improvements to the video streaming API. We have some fixes for Android O compatibility, and Android O did change quite a lot of things around in Android, especially in inter-process communication and locking down the threads against each other. So we're looking through that and kind of like going and catching up with the changes that they made, like we do with every version of iOS or Android that comes out. We do the adoptions we have to make it compatible. So again, Hello World, also available for Android, of course. You can check that out. It's all in Java, and you can look at a very basic example, very similar to what we do on iOS. Generally, try to mirror all the tools we have for iOS, also for Android, so that you guys can use them whatever language you're using. And then compatibility on Android works a little bit different. So the currently minimum Android version we target is 2.2, which I'm not sure if anybody remembers that. It's a long time ago. It's really funny if you try to find a phone that actually still has that version. But we can go as low as Android 2.2. And then for Android, there's also something called the target version, which we support 4.4. If you're an Android developer, you're probably going to know what it is. If you're not, and you really want to read something up, and you got through the NHTSA specification, and you know everything about driver distraction guidelines, then you can go to this link and read about minimum version and target version and get really confused about why Android is so complicated. Also, we have RPC Builder for Android. So if you guys want to check out, and you only have an Android phone at hand and you want to check out how RPCs work, we have basically the same tool that we have for iOS, also for Android. It has a little bit limited feature set. We're currently building it out still, but it's the same deal. So you can connect and you can dynamically create these kind of interfaces and dynamically create the RPCs that you can send out through the mobile API XML that you see in like the file input in the application. And so that gives you the same access to the system and the ability to try stuff out. Also looks very similar, so you know it's the same thing. They got some inspiration from one another. The next thing I want to talk about real quick is the core. So this is the part that actually runs on the head unit. And this is kind of an architectural drawing of how SDL works. And I just want to give you a feeling of what SDL core really does. So the core part is the one that I'm going to highlight in red right here. And the idea of the core part is it takes the input from the app on one side through whatever transport manager, be it USB, Bluetooth, or Wi-Fi, and it translates that to all the internal systems of the infotainment system. So the infotainment system has a display that will write text to, it has voice recognition, text to speech, the buttons, vehicle data, and everything that's like based in the embedded infotainment system. SDL core translate everything that comes from the app and then brings it into the embedded infotainment system, and basically is a translator between these two sides of the system here. So when we look at that, this is actually an application which is written in C++. So for embedded devices, it's POSIX compliant. We do have an HMI that looks like this for it. We currently support QNX and Ubuntu. So if you go online and download the core software, you can run it on Ubuntu. And if you see the Ford emulator, that's running on Ubuntu, currently 16.04. You can run it on Ubuntu, and then when you want to talk more about embedded devices, it runs on QNX out of the box. You have to do, of course, a couple of connections to the proprietary QNX drivers, but generally you can compile it for QNX. We don't have official Android support. We have a lot of people asking us that if we support Android on the core library. At this point in time, we don't officially support it. We don't have a production partner that's actually working with Android yet. But as this is an open source project, if any of the OEMs or anybody else is interested in porting their project to Android, we're more than happy to accept that contribution back into the project and make Android a supported platform. But because we didn't have the need yet, we didn't port it, although we've seen it working, so there are people that made it work already. We just didn't adopt it officially. And then we have WebSocket connections to the embedded system. We do have a web HMI, which you see on the top right. So it's basically an HMI setup for core so that you can interact with the core system. It is built in HTML5 and JavaScript, but it's kind of out of date. And so when you see it online in our repository, we're currently working on getting it updated and getting it to support all the new features. But it's not necessarily recommended to check out all the newest stuff we're doing. So this is a pretty long slide, a lot of text on it. What I did for this is I basically just took the text out of the proposal because it's kind of nice to see how we propose things to the SDL consortium. And this is one of the proposals that the Livio team, the maintainers, put in a couple of weeks ago for a new tool that we need in the SDL consortium. So one of the problems we have is that OEMs implement core and then they have to test core. Now, how do you test it? Every OEM has to test it in a very similar way, but currently there's no unified tool to do this testing. So you can use RPC Builder, you can write your own tools to test, every OEM can do it differently. And so this is the way we proposed, this is part of the proposal for the hardware validator app. And what it should do. So the way you should be able to script it. So the idea is you have an application after you've done the implementation of smart device sync on your head unit, you have an application to test it, to do scripted testing, to run through automated tests so that you have a validated SDL implementation on your head unit. And so this app is not existing yet, where we had the proposal, it was accepted, and so we're going to go to the next step to actually build this app. But when you go in and go to that URL that I put on this slide, and we're going to make these slides available so you guys can have a look later, and there's a lot of links in here that you can go and look up. And if you look up this hardware validator app link, there's the whole proposal in there that will give you a really good idea on how this validation of your hardware will work and how this validator app will work to do certification of SDL implementations on head units. Let's get to the documentation. So the documentation really is one of the most crucial parts of the SDL consortium, just because I talked before how important developers are, and one of the key points to get developers on board and keep them on board is giving them good documentation, because they don't like to be stalled, they don't like to not know how to do stuff. They want to read up how something works and then just implement it really quickly. So you can go to smartdevicing.com, and we have two different types of documentation up there. We have tutorials or guides. These guides will help you to achieve specific functions. For example, initial installation, sending a number to the head unit, showing something on the screen, getting input from the user. So these guides are step-by-step guides and explain you how to do things with the system, how to interact with the system. And then we have reference documents, and the reference documentation will actually go and help you by going through every class in the system and with an explanation of every class in the system. And that is all hosted on GitHub. So when you go to the guides, what you can see on the bottom of all the guides, every guide has this little link on the bottom that I put into the red rectangle. When you go to smartdevices.com, look at a guide, scroll all the way down, you see that view on GitHub link. So let's say you read a guide and you're like, that seems wrong, it doesn't work for me, something is wrong, there's a typo in the guide, I don't like the word you used. What you can do is you can go to the GitHub page, click on that link, go to the GitHub page, and then just open an issue. So on the bottom right, you see a couple of issues we currently have open against, I think it's the Android documentation. So you see it's basically like a task list for us. So for us, we got to improve the documentation constantly, and to keep track of what we have to improve and what we have to change, we use GitHub for an issue list. And so whenever we find an issue, we open it up. So actually all the issues that are in there are either from the maintainers or from Ford side. And so we want to improve the documentation at all times, and we use GitHub a lot for that. And we appreciate all help we can get from the developer community or for OEMs or even from users, whatever. Like everybody who's part of SDLC can put in an issue in here and help us to improve the documentation. So there's a big part that I want to get started on, which is the app ID and centralized app IDs. So we're basically done with all iOS, Android, and Core, and did all development. Now, when your app is ready and you want to bring it to the market, you have to get an app ID. So we centralized that as well. So the app ID is unique across all the SDL consortium. To get an app ID, you can go to smartdevices.com, create an account, create a company in there, and then you can create an app ID like I did up here. So you can see my app ID up there. And this basically helps you to obtain the app ID, kind of give your meta information, register your app, and in the future this app ID will be automatically then communicated to all the different OEMs, and everybody will use the same app ID. Everybody will know your metadata, everybody will know what kind of special access you would like to the systems and what vehicle data items you would like to have. And this works with our shade system. So the app ID in there, when you look at this kind of chart on the right side, you see the shade server on top, and we talked about this earlier a little bit, the super helpful application information database. This database holds all app IDs. And when you think about it, every OEM has their own backend system, because every OEM would like to keep control of what can be accessed on their car. But the shade is kind of the central server that holds all the information that gets distributed to all these OEM systems. So shade is the master. You register your app with shade, you register your app on smartdevices.com, put your data in there, and then the OEMs can automatically retrieve that data from that server to add it to their own systems, and finally then to transmit that to their head units. Because there's no direct access from the smart devices consortium to the head units of the OEM. That all goes through systems that are hosted by the OEM themselves. Another tool that we use on smartdevices.com, which is really helpful, is SDL Core and Mentor Core. So for Mentor Core, we talked about this a little bit earlier as well. It's basically a core instance running in the cloud. So if you want to test an SDL app, but you don't want to download a virtual machine, you don't want to compile core, you don't want to use the Ford implementation and download it from developer.ford.com, you can go to smartdevices.com and start up a Mentor instance. You start it up in the cloud, basically starts in the browser, looks like that, and you just connect to an IP address and a port that the web application shows you, and you can interact with that the same way as you would interact with a car. So you can take the same app that you developed against Mentor Core and then plug it into a Ford vehicle, and it would just interact the same way. Based on the template, it will look much different because the templates are very different, but your content that you want to display will still be there. Now we come to a topic that will need a minute to explain, but it's a very, very crucial part of what SDL is. So we do what we call policies, and policies are what actually controls access to for the applications on the head unit. So policies govern the access. We have a couple of examples, for example. We don't want to give everybody access to the vehicle data. Now, the policy server actually governs what apps get access to what vehicle data items. How this works is basically the head unit, or there's a typo in there, so not the app sends out the policy request, but the head unit sends it out. So the head unit recognizes a new application that just connected. The head unit sees that the app connected the first time. It will go and communicate with its backend system. So the head unit goes out to the server of the OEM, says, hey, a new app just connected, this is the identifier, what can this app do? Now the backend system knows this app because it pulls it down automatically from Shade earlier and has the permissions set up on the backend side. And the backend server creates what we call a policy table response based on the information it has in its database. So for the hackathon participants, before you were able to use the vehicle data or the dial number RPCs, you had to talk to one of the Ford people on site to add you to a specific database. This is our backend system where we added your unique ID with your access possibilities. And so when the request comes into our server, it will gather your information and will package up the policy table response, send it back to the head unit. The head unit will look into that JSON file, see your unique identifier, and will get information about what kind of services you can access. And then we'll go through the flow of asking the user if you really want to share the location, for example, with the application. So policies is a very important part to any SDL implementation because it's the one that allows the OEM to keep control over everything that's happening in the car. And it's really just a JSON file. You can see a little example on the right side. If you really want to know how it works, go to GitHub. It's all up there. If you still don't understand, which is very likely, come to our Slack channel and ask all the questions. We're happy to help, and we usually can answer whatever you guys throw at us, so don't worry. And for this server, the server that actually creates the policy table update, we created what we call the SDL server. So the SDL server is an example server that manages the backend system. Now, the thing with the backend system is, even though every OEM wants to host their own backend system because it's all proprietary data to the OEM, what they don't want to do is develop the backend server. They want to host it, they want to have the data locally, but you don't want to develop it yourself. Every OEM needs the same backend server anyhow and run their own instances. So in the Smart Devices Consortium, we took it upon us to actually create an SDL server ourselves so that can be downloaded by every OEM and then run in the IT environment of every OEM. So we have what is called the SDL server, again, online in the GitHub repository. And it will respond to policy table requests and compile the responses and package up the table and send it out. We're currently working on making it absolutely complete with like a web interface for the OEM backend side, so that the engineers of the OEM can say, app, for example, app YZ gets access to vehicle data and gets access to location, and these kind of web interface towards the engineers is currently being designed and being built. But this is really, the goal is to have this as a turnkey solution for SDL members so they can download it, host it in their own cloud, and then run it against their own head units. And obviously also for this, continuous development will make it better and better over time, and all the members of the SDL consortium will have the benefit of the improvements of the server system. SDL organization, we're going to talk for 1 second over the SDL server actually. So it allows the management of the backend system. Oh, there's a double slide in here. No, I want to talk about that. So SDL organization. So we talked about the SDL evolution process. So everything that we do and everything that we improve has to go through our teams to discuss this with all the members of the SDL consortium. So you see here how the SDL actually works with the SDL evolution items, and you go from proposal to steering committee, discussion, and then into a decision of either accepted with changes or rejected, as Joey pointed out earlier. What I want to show you a little bit is the traceability I talked about in my first presentation as well. So the traceability is really important for us. So when you go into GitHub and look in the SDL evolution process, you will see a lot of issues in that repository. In these issues, we discuss the proposals. So they're not really issues, but more like items we discuss. So we discuss, for example, this one, which is a refactor of an RPC in the Android library. This is a point where that we discussed. You have that in there. This was accepted a while ago. It says May 17th. And when you go and open that up, what you can see is the issue itself. So this is how we open up the discussions. You have a link to the proposal, and you have kind of like a guideline of what we're going to do for review. Now you scroll down, and when you scroll down, you have your discussion. And after the discussion is done, and after we accepted the proposal, hopefully, you will have an entry like this. And so Teresa is our great help, project management help in the Maintain Olivio team, who is actually doing all the work of creating this traceability. So as said before, it's been done automatically, and she protested. So sorry for that. No, it's all done by hand, actually, by by Teresa. So thank you. So we create this issue, and now the issue, so from this repository, the SDL evolution repository, we create a link to the SDL Android repository. In the SDL Android repository, we have a new issue entered, which says Android RPC refactor. When we switch over to the Android repository, you can see this issue, and it basically links back to the proposal. So you can go back and see the proposal and see what we did there. And here, this is a work task for our Android library. Now this work that was accepted in the evolution process has to be actually done. So in this issue, you can see a little bit further down, Austin did the coding and actually merged in the new feature and the refactoring of the RPCs. So when you really want to know what changed, you can even click on that link, which will take you to this page. And so in here, you can see the Git commits and the actual source code changes. So we provide this end-to-end traceability of what we're doing, which is a really nice feature of I have to move. Check one. I'm not sure. Is that pushing here? Push? No. Check. Help. Probably you guys can hear me as well. I assume. Does that work in the back row? Because somebody will figure out the audio issues, and I'm gonna just talk like this until then. Again, traceability is really important for us. We really want to be able to see what we're doing from beginning to end, to also show off the work we're doing. All these 94 evolution items we have, that is all workload that gets created and code changes that we're doing. So we're really proud that we have these kind of traceability now. So if you go to this link down here, thanks. If you go, oh Jesus, that's a 1 2 1 2 1 2 1 2. Okay, we got this. All right, sorry guys, I really didn't want to wake you up. Let's check this. Okay, so the smart device link link that is down here is a status page of all the proposals. So if you want to have a quick overview of what we're working on currently, you can go to that link and you can see the active reviews. These are actually the ones that we're going to talk about in 45 minutes. The awaiting implementation ones that still have to be implemented, and then we have also stuff that is already implemented further down the list. So this URL gives you a quick overview around what we're doing and what is currently being improved in SDL. And that's the end of the presentation, actually. So I would like to open this up for a couple of questions. I know there's a lot of content. What I try to bring across is that the SDL consortium really tries to encapsulate all the workload between libraries on the mobile, core, but also back-end systems. So there's a lot of stuff going on in the SDL world. We're working on a lot of different fronts and improving the system, and we're really happy about any help that we can get. So if you guys want to contribute, if you're already a gold member or diamond or platinum member, you can join our steering committee calls. Otherwise, if you're not already a member, you should become one to join the calls and help us. And with that, I'm gonna just open it to the floor, and if you guys have any questions, you probably gotta shout because I have your microphone. Or we have to wait. Maybe it's also overwhelming, so maybe there's no question. Okay.
Hello? Yeah, we're
All
on.
right.
All right, who's got a question for Timur? Come on, he gets paid by answers. Let's go. None? Not even, hey Timur, why didn't you take your badge off when you're on stage?
Yeah, why don't you take a badge off? Why don't you have a mic in your hand now and not a lapel mic as you had before?
Yeah.
Why did you forget to go back and get your mic up? It's like all the questions we have. No.
Well, you got Logie after lunch. I mean, that happens to everybody, right?
Yeah, right. So if you don't have a question, but something comes to your mind tonight when you think about SDL in bed and you can't fall asleep, then go to our Slack channel and ask your question there. We're around, and so I'm happy to help, happy to answer all your questions. Oh, there's one.
Now I gotta walk all the way over there?
Scott, yeah.
People obviously don't know how lazy I am. Who had a question? Of course, Richard, thanks.
So it has to do with Manticore, which we've been playing around with while paying attention diligently to everything you're saying. But we were checking out Manticore, and it's cool, and it works really well, and it's really a nice idea because it saves the trouble of installing like VMs and all that. So thumbs up. But we noticed that our application that we wrote last night renders differently. And I was thinking more about different OEMs and how they can choose to implement the templates well. And I'm wondering what your guidance to us would be, knowing that, at least in the case of the Manticore, it looks like the templates, well, certainly our app looks very differently on Manticore than it does on the other apps. If you have any guidance for developers to make sure that our apps will look beautiful on all the different OEM implementations.
Does it work the same?
It looks very different, and it doesn't quite work as well, which could be the app's fault.
Yeah, so I can't really comment on the app quality. I'm sure it's great. But so when you talk about Manticore and like the different templates, for one of the real big challenges for us, but also one of the most important thing is to make these templates different but work the same. So your app will always look different. That is just the nature of templates. So if you have a Toyota system, a Ford system, and a generic Manticore system, these templates will be different. Manticore, you can see, was done by mobile developers, so they like black. It's all black with them. It's all like dark colors, and it's really nice. For an automotive system like the Sync 3 system, we will see it's really light, because when you're in the car and you have the sun glaring in, you got to have a bright screen to be able to see anything on the screen. And then you have a dark mode at night, which is really dark, and you try to not create any light into the driver's face while they're driving. So all these templates will look different. There is no doubt about it. We make sure that they all function the same and the app works the same way, but you cannot expect to have it look absolutely the same on all of these implementations. Like, was that the ice?